Next problem, find the equation of the ellipse whose distance between foci is 4 root 2, center 0, 0, length of the latus rectum 4, and major axis is y axis. So they have given 2 points, center is 0, 0, major axis is y axis. So ellipse should be in vertical shape, right? Major axis is y axis, right? So here focus is S B 0 comma B, right, and S dash 0 comma minus B. If it is the major axis is the x axis, then AE comma 0 minus AE comma 0. Note that is the difference. And similarly, latus rectum, they are suppose x axis is the major axis, then 2b square by A, length of the latus rectum. But in this case, because y is the major axis, so in this case 2a square by b, so you have to change accordingly. Let the equation of the ellipse is x square by a square plus y square by b square equal to 1. That is equation number 1. So this is the ellipse. So and distance between the foci s dash is equal to 2b, right? 2b is equal to 4 root 2. So b is equal to 4 root 2 by 2, that is equal to 2 root 2. That is equation number 2. And length of the major axis, right? Sorry, latus rectum 2a square by b. So 2a square by b is equal to 4. So a square by b is equal to 2. So a square is equal to 2b. That is equation number 3, right? So we know that a square is equal to b square into 1 minus e square, because everything will change here, right? Because the ellipse is in the vertical shape, right? That is y axis is the major axis, right? Instead of a, you replace a by b, b by a, right? Using 3, 2b is equal to b square into 1 minus e square. 2b is equal to b square minus b square minus e square. So 2b is equal to b square minus 2 root 2 square, right? So 2b is equal to b square minus 4 root 4 into 2. So 2b is equal to b square minus 8. So we are getting quadratic in b square minus 2b minus 8 equal to 0. So factorizing b square minus 2b minus 8. So b minus 4 into b plus 2 equal to 0. So b equal to 4 or b equal to minus 2. So b equal to 4 is the possibility. So b cannot be negative because length. So b is equal to 4. So b is equal to 4 in 3. So you will get a square. A square is equal to 2 into 4, that is equal to 8. So b square is 16 because 4 square. A square is 8. Put it in the 1. So you will get the required equation. X square by 8 plus y square by 16 equal to 1. Next problem. Find the eccentricity of the ellipse. If the length of the latus rectum is equal to the half of its major axis. So let the equation be x square by a square plus y square by b square equal to 1. Length of the latus rectum is equal to half of the major axis, right? So length of the latus rectum, we know formula 2b square by a. Length of the major axis 2a. Half length means a, right? So they have given 2b square by a is equal to a, right? So 2b square is equal to a square. So that is equation number 1. So we know b square is equal to a square into 1 minus e square. Using 1, b square is equal to 2b square into 1 minus e square. So 2 1 minus e b square get cancelled. 2 into 1 minus e square is equal to 1. So 1 minus e square is equal to 1 by 2. E square is equal to 1 minus 1 by 2, 1 by 2. So e is equal to plus or minus root of 1 by 2. So we have to take positive value. So e is equal to root 1 by 2. So 1 by root 2. So eccentricity e is equal to 1 by root 2, right? So that is what we need to find. Next problem. The distance of a point on the ellipse x square plus 3y square equal to 6 from its center is 2. Find the eccentric angle, right? So given equation of the ellipse is x square plus 3y square equal to 6. That is equation number 1. So divided by 6. So we are writing it in the standard form. X square by a square plus y square by b square equal to 1, right? So x square by 6 plus 3 by 6 y square equal to 6 by 6. So we will get x square by 6, that is a square. A square is equal to 6 plus y square by b square. B square is equal to 2, right? So a is equal to root 6, b is equal to root 2. So let p a cos theta comma b sin theta be the given point on 1. We are taking parametric points, right? Because we need eccentric angle, right? So angle which is only available in the parametric equation. So parametric equation contains the theta, that is why we are taking, right? Easy to understand, right? Such that distance between P and the center C0, 0 is 2. So the distance PC is equal to 2. That is equation number 2. So PC is equal to root of, we are using the formula, distance formula, a cos theta minus the 0 the whole square plus b sin theta minus 0 the whole square, right? So PC is equal to root of a square cos square theta plus b square sin square theta. So a is equal to root 6 and b is equal to root 2. So from 2 and 3, so PC is equal to, substituting the value of a square b square, 6 cos square theta plus 2 sin square theta, that is equation number 3. So from 2 and 3, the distance 2 is equal to root of 6 cos square theta plus 2 sin square theta. Squaring both sides, 2 square is equal to root of 6 cos square theta plus 2 sin square theta, right? So square root will cancel when you are squaring, right? So divided by 2. So 2, which is equal to 4 by 2, 2. So 6 by 2, 3 cos square theta plus 2 by 2, 1 sin square theta. So cos square theta is equal to 1 minus sin square theta. So 4 becomes 2, which is equal to 3 into 1 minus sin square theta plus sin square theta. So which is equal to 3 minus 3 sin square theta plus sin square theta. So 2 is equal to 3 minus 2 sin square theta. 2 sin square theta is equal to 1. Sin square theta is equal to 1 by 2. Sin theta is equal to plus or minus root of 1 by 2, that is 1 by root 2. So theta is equal to pi by 4 or pi minus pi by 4 or pi plus pi by 4 or 2 pi minus pi by 4 or 2 pi plus pi by 4, etc, etc. So all are getting the same value because plus minus values, right? So we will get theta is equal to pi by 4 or 3 pi by 4, 5 by 4, 7 pi by 4 or 9 pi by 4, etc. So theta is equal to 2n pi plus or minus pi by 4, where n is an integer. Thanks. So we are using the distance formula, PC distance. You assume that P is on the ellipse, C is center. So we are using the distance formula. That is why we are getting PC, the distance, right? Thanks.